All right, good morning, everyone. Thanks again for taking time out to come down to the AWS Loft and learn about AWS big data and analytics solutions. My name is Ben Willet. I'm a solutions architect with AWS. With me here today is Juan Yu, who is a solution architect who specializes in data warehousing and Redshift in particular. Today we're going to co-present a session on AWS databases and analytics. So let's talk about what we can expect for this first hour session. You're going to hear about the new AWS database and analytics solutions that were announced at reInvent. You're going to understand what the overall AWS database and analytics strategy is and our portfolio of services. Initially, I'm going to throw a lot of different service names at you, but during the course of the next 3 days, we're going to dive deep into many of these, and you'll get a more fuller understanding of what these products do and how they fit together. So if at first it seems like alphabet soup, don't worry, we'll go through each of these category by category, service by service. And then finally, as we present the services and customer stories about how AWS customers have successfully implemented these services, you'll start to get a sense of how you can apply these services and patterns to your own organization. And again, there'll be a workshop following this session where helpers will be available to discuss not only the workshop content, but also how this may directly apply to your environment and your workload. So feel free to ask us those questions as well. So again, you've heard AWS folks talk about the just massive customer engagement in terms of uptake of database and analytics services. I'm not going to go through all these logos today, but you'll hear more about folks like the NFL that are using QuickSight for their next-gen stats platform. You'll hear about Epic Games using DynamoDB and data lakes to achieve massive scalability. And you'll hear about Edmunds.com, who's using Redshift to deliver sub-second query response. These are just a few of the customers we'll talk about today. If you have interest in any of these other use cases, I encourage you to just go to the AWS site or just type in AWS Adobe and hear about what the folks at Adobe are doing on our platform. So again, these are all publicly referenceable, and you can just search our site to get more information. Again, massive number of startups using AWS database and analytics services. It's kind of funny here when I look at these names, Reddit, Pinterest, Airbnb, and Lyft, to think about these guys as startups when they're billion-dollar, multi-billion-dollar companies now. And again, they've been able to achieve a lot of the scalability. You'll hear more about some of these use cases and the transaction volumes that they're running on AWS databases later in this session. But again, Lyft, for example, uses DynamoDB to do real-time GPS tracking of vehicles. So when you're looking at your phone and you're watching that little dot move around, those are actually DynamoDB calls powering that dot. So some high-level stuff on our strategy, and this is some stuff we came up with back in 2010. An explosion of data. You guys are living with this today, right? This is something you face every single day. The cloud is going to enable a fundamentally different architecture. So when I was building database applications on-prem, typically I had a server or a cluster, and I had a procurement process, which was for me to write out a very clear business justification of why I needed $1 million for a cluster. That went all the way up the chain and came back down and went back up and came back down. Finally got approval for the cluster, implemented it, and then what's the worst thing that happens? You're successful. And then people want to get on your cluster, and they say, hey, Ben, can I run my workload on your cluster? You say, oh, okay. And then, hey, I heard Ben's got this okay, come on. And then what? You're maxed out, and you need another cluster. You need more storage. And so the cloud enables a fundamentally different architecture where we have scalability in terms of growing our workloads out. We have the ability to provision on demand in real time, so spinning up hundreds, thousands, or even hundreds of thousands of cores in real time, crunching our data. And then if we need to, we just throw the cluster away and we start over the next day. And then one size will not fit all. So I come from a relational database background, and I'm very used to, the traditional way of just taking your data, running some ETL, building a relational schema, putting it in there, and then getting the benefits of a relational database, right? You get ACID properties, you get transactions, you get durability, consistency, right? But what we're finding now is, as we talk to more and more AWS customers, they're coming to us with diverse requirements. Like, for example, they need a key value store. They need consistent millisecond response time. Maybe now they want to do a time series database to track IoT data. And so what we found is there is not a one-size-fits-all database solution. And so AWS took the approach, instead of trying to cram every single feature into a relational database, we're going to have separate engines for separate workloads. And we'll spend a lot of time this week talking about what those different engines are and the workloads they support. So let's dive into it. So again, a pretty broad and deep portfolio of purpose-built databases for builders. We'll start at the very basic, which is data movement. How do you get data into AWS, right? So we've got a couple of different services here. We've got the AWS Database Migration Service that you're going to hear more about. That's how you physically move rows from one database to another. And they don't have to be the same. You can move rows out of your old legacy Oracle database into Aurora Postgres, and Database Migration Service will get you there. We've got appliances like Snowball, which is a ruggedized data appliance. I think they're up to 100 terabytes right now. Go into the console, order a Snowball. We'll ship you this device, load 100 terabytes of data on it, ship it back to us. We'll copy that up into S3 and send you a notification when your data is available. If 100 terabytes isn't enough, we've got a truck called the Snowmobile with 100 petabytes on it. And we'll actually send this truck for your facility. We'll run fiber into your building, and we'll put 100 petabytes on this thing, drive it back. The internet is amazing. We've got a service called AWS Direct Connect, where we can provide increments of 1 gig or 10 gig network between your on-prem facility and AWS for low latency, low jitter connections. But at a certain data volume, it turns out that FedEx is actually the fastest connection you can get. And so these Snowballs with 100 terabytes, or the Snowmobile with 100 petabytes at large scale volumes can actually be faster. And then we'll talk a lot about Kinesis, which is real-time streaming services from AWS. And this is an example where you've got data coming in real time, and you want to be able to process those events in sub-second. Cool. So above that, we now have moved our data into the AWS cloud. Well, where does it go? Typically, at customers, we'll put data in S3. This is our scalable, durable, secure object store, extremely low cost, starting at 2.3 cents a gigabyte a month and going down from there, right? We've got single zone S3 for transient data as low as 1 cent a gig. And then we've got Glacier for archival data at 0.4 of a cent a gig. So if you've got compliance requirements where you're a pharma company, you're a financial services company, you're a manufacturing company, and you need to keep historical data, load it up in S3, do your processing. When it's fresh data, it's hot data, work with it there. And then when it's older data, you don't have to delete it, right? You can now afford to keep every byte of data and just migrate it down to those lower cost storage services like single zone S3 or Glacier. And then ETL, right? So you guys are probably familiar. How many people are using AWS Data Pipeline today for ETL? Okay, so I can talk a little bit about that. And how many people are using AWS Glue for ETL? Okay, a few folks. Great. So again, we still have the traditional workload of ETL, right? We've got to get your data out of one system, we've got to do some cleanup, and then we've got to get it ready for loading into the target system. And AWS Glue is a relatively new service that allows you to build a fully managed serverless ETL job. So you go into the Glue console, you've got a graphical pipeline builder, you apply the source, you apply the transforms, you apply the target, and you've got your graphical ETL job laid out there. One of the things we heard from customers is their dissatisfaction with existing ETL tools is that there's always that last mile problem. There's always that one transform that the tool doesn't provide. And so they wind up just throwing the tool out and writing the entire transform by hand in Python, right? What we're doing with Glue that's fundamentally different is we're supporting containers where you can use Python to basically develop that last mile transform and then plug that container into Glue's framework as if it's just another step in the pipeline. And then we'll scale up that script across our serverless fleet so that if you've got a month's worth of data or a year's worth of data, we can process that ETL in a consistent amount of time. And so actually, before we go ahead, so we can talk about the combination of these two services of S3 and Glue into a new service that we announced at reInvent in December 2018 called Lake Formation. And what Lake Formation is going to do is it's going to allow you to easily and securely build these data lakes on AWS by providing a framework to create your S3 source and targets. This is where you're going to store your raw data, your process data, your interim data files. Create your ETL jobs for managing those transforms, and do it securely with a very fine-grained permission set. And so Lake Formation's in preview right now. It'll be available, let's just say shortly. And I encourage folks who have built data lakes in the past by hand to take a look at some of the nice automation that Lake Formation's going to provide. So now we've got data in S3, we've got it transformed, we've got the data cleaned up, it's ready to be looked at. We've got several analytics tools to process that data with. So again, I'm going to throw a lot of different services at you today, but don't panic. We're going to go through many of these in very fine-grained detail over the next 3 days. And again, we always have solution architects and experts here to answer questions. So if we look at the analytics layer here, we've got Redshift, which is our petabyte scale managed data warehouse. We're going to talk a lot about that this week. We've got EMR, which is our managed Hadoop and Spark framework where you can very quickly and easily spin up clusters, run your workloads, and again, have the scale to suit your performance requirements. We've got Athena, which is the ability to run ad hoc SQL queries directly against S3. So you've got an ANSI SQL front end where you're doing select star from tables, but you haven't actually loaded that data into a data warehouse. You're able to use the Glue catalog, which we'll talk about in more detail, to query directly against the underlying S3 files. And the great thing about that is, and when you're first formulating your data warehouse strategy, you may not have the star schema clearly in mind. You may not have your fact tables and your dimension tables really solidly formulated. And Athena is going to allow you to run ad hoc SQL queries where you pay for only the data that you scan and then start to formulate your plan against that raw S3 data. And then when you have your access patterns defined, go ahead and load that S3 data into Redshift for that highly optimized, massively parallel data warehouse. And again, use standard SQL to access that. And then Elasticsearch, we won't talk about too much this week, but again, fully managed Elasticsearch service. And then we'll talk a lot about Kinesis data streams, again, for streaming ingest of real-time data into AWS. You could think of this as Twitter tweets coming in, or stock quotes coming in, or IoT data coming in, where you want real-time millisecond access to that data. So again, we've got a bunch of analytics tools that are going to allow us to prepare that data and make it consumable by your business analysts. And so at the top, we've got Amazon QuickSight and Amazon SageMaker. QuickSight is our business intelligence tool, and it's going to allow you to build graphical dashboards and do what-if analysis on that data. So for example, you've got your data in a data warehouse now, and you want to build a QuickSight dashboard that shows how many widgets did I sell in January in Seattle of a certain type, or show me, average unit price for a specific product. How many PlayStations did I sell at Christmas last year, for example? QuickSight's going to allow you to very quickly and easily build dashboards, discover data sources, and then share that analysis out with your coworkers with very, very low pay per session pricing. SageMaker, on the other hand, is aimed at developing, training, and then deploying machine learning models to your applications. So again, we really want to democratize data science and machine learning. If you've got folks that are in there programming to these frameworks directly, whether it's TensorFlow or MXNet or PyTorch or some of these others, that's great. But for the rest of us mere mortals, we've got SageMaker that's going to allow us to go in, create a Jupyter notebook, start building out a model, go ahead and train the model. And again, SageMaker has been optimized to take advantage of the AWS fleet. The algorithms we provide in SageMaker are designed to scale across a massive number of GPU instances for very fast training, and then provide that model out as an endpoint for your applications to do inferences on it. So you've gone into SageMaker and you've defined your model, you've tuned it, you've made it available to your application, and now you can start saying things like, is this order fraudulent? Should I approve this credit card transaction? Is this API call coming into my application legit, or should this be traffic that I'm blocking? And we'll see some examples of these applications later. Sure.
You said Glue has some gaps in terms of bigger transformation. Can it be plugged into Python to do some Glue transformation, but you want to use it inside Python or do whatever you want to?
Yeah, that's a great question. So I mentioned earlier that if there is a particular transform in AWS Glue that's missing that you need for your particular workload, the question was, can I write that myself? And absolutely. So using Python and I believe Scala too, you're able to go and write your transform in Python or Scala, upload that to Glue, and then have that be a step in the pipeline, just as if it was a native AWS Glue step in the pipeline.
Take on the Glue transformation inside the Python. You want to do it or something else?
Okay, so that's a great question. So now, what if we go the other way and we have a Python app? Can we call Glue from that and have Glue just be another step in the pipeline? And the answer is yes. So we do provide full API access to Glue as well.
You said Athena is mainly, you position Athena more for discovery kind of thing, so that before you go to optimize. But I heard from last time data lake formation, Athena can be used as a standalone if the performance metrics are good enough. But how do you position? Are you positioning it as the three-step for query optimization, or you can go in parallel with
Yeah, that's a great question. So it was, do we use Athena as this ad hoc query tool while we're learning and preparing our data, or can we just use it as our production query and SQL interface to our data? And the answer is both, right? So some folks may find that this ad hoc analysis, whether they're literally typing SQL into the Athena console, or maybe they've plugged a SQL client or a BI client into Athena, that may be their end-to-end data solution. They may have a QuickSight to Athena to S3, and that's all they need to do to accomplish their business analysis. I think you'll find the performance on Athena. We'll talk a little bit about the implementation later. The way we do distributed query processing across the AWS fleet. People get great performance running directly against S3. If you want to go the next step and build a Redshift cluster for your data warehousing or use EMR, these are all great approaches. And again, my job as a solutions architect is to dive into your workload, understand exactly what you're doing, and then help you make a determination of whether it's Redshift, EMR, or Athena, or some combination of those. Yep.
What you get out of Kafka, because Kinesis is already there for a very long time.
Yep.
There are specific use cases that Kafka is better than Kinesis?
So the question was, AWS recently started supporting a managed Kafka service. And so how do I decide between Kinesis and Kafka? Because there is some overlap in the feature set. I'd like to parking lot that for either during the break, or if you're here on Wednesday, we're going to do a deep dive on streaming. And we can talk more about the pros and cons of Kinesis versus Kafka.
More on the SageMaker. Both QuickSight and SageMaker can work with any of these layers, like either Athena or Redshift, doesn't matter, whichever way you want to query, you can seamlessly work with that.
Yeah, so the interface, the question was, how do QuickSight and SageMaker work with these data sets? And so QuickSight is going to use either an ODBC or a JDBC connection to access data. So any tool that can expose an ODBC or a JDBC interface will be able to plug and play. QuickSight is also natively aware of your AWS data services. So if you allow QuickSight to, it will actually go and do some introspection in your account, and it'll say, hey, you know what? I found a Redshift data warehouse. You know what? I found an S3 bucket. I found an RDS database, and it will provide you pointers to those data sources.
There's no push-down optimization on this one, like SageMaker cannot push down the workload to Athena or somewhere and execute and get the output data set, or where does it get executed in the SageMaker cluster itself?
Yeah, so the question was, does SageMaker push down any of the analytics or the training work to these other services that I'm talking about? And the answer is no. SageMaker will have its own cluster of GPU instances that you define to do the training of the model. Yeah. Okay, so let me take one more question and then try to speed up a little bit.
I would just a comment. I would propose shifting around the question so the time is not monopolized by one person for fairness. And two, is there an on-the-fly OLAP creation tool within your analytics stack? The analytics layer. If you want on-the-fly cube creation, like tools that we used to use in Stony stuff, space, is something like that available in the current tool sets, the 5 of them that you have?
Yeah, absolutely. So the question was, can I build cubes and pivot tables and things like that interactively? And QuickSight is going to allow you to basically point the tool at a data store and drag and drop columns and graphically build pivot tables, graphically build charts. And we do that by moving your data into memory for extremely high performance. And Juan will have some slides on QuickSight a little bit later. Okay, so let's try to make up a little bit of time here. So we talked about analytics tools, and again, you'll hear a lot about purpose-built databases today. So AWS has a range of relational database offerings under our RDS service. So this is a fully managed interface to relational database products like MySQL, Postgres, MariaDB, but also to commercial engines like SQL Server and Oracle. We've got NoSQL databases, we've got in-memory databases and graph databases, and then we recently announced a ledger database and a time series database at reInvent, and we'll talk more about those later. And then again, blockchain is huge these days. You're hearing a lot about that. We offer a fully managed blockchain service, and we also offer some templates where we'll give you the blueprints, and you can spin up blockchain on your own EC2 environments that you manage yourselves. But again, I know this looks like a lot of services. We are going to cover these in more detail as we go. So again, as solution architects, Juan and I go out every day and we talk to customers and we understand their workloads, and we see a couple of different themes emerging. And so Juan is going to come up and talk to us about the first one, which is how to gain new insights from the data you already have. So you've collected a lot of data. How do you unlock the value? And then I'll come back up and talk about building new apps, and then Juan will come back and talk about lift and shifting existing workloads into the cloud.
Thanks, Ben. So let's talk about the first type of workload, gain the new insights. So traditionally, if you want to analyze your data, you put your data in your data warehouse. And the traditional data warehouse usually is very hard to scale. So they're able to hold probably 100 gigabytes of data and up to a single-digit terabytes. The only thing big of those type of data warehouse is they cost you a lot. They're big bucks. So a typical traditional data warehouse, besides the big initial capital expense, and additionally, it will cost you like $10,000 per terabytes per year. And if you use a high-end data warehouse, it can easily cost you like 50,000 terabytes, $50,000 per terabytes per year. So with such a high cost, you're motivated probably to throw a lot of your small data because you cannot afford to analyze them. So our design principle is we think all data has value. We want to help customers to analyze the majority or all of their data. And also, we think that the data is a great tool that every employee in your organization should have access to have all the data and cheaply so that they can be prepared and they can make the sound decision. So data warehouse is the one way to analyze your data, with the data coming from all type of applications. So there you can have the CRM, you can have your relational data, you can have your non-relational data. And just the data warehouse is not enough to solve all kinds of analytics issues. You need a data lake to be able to handle different use case, different situation. The best place to build a data lake is S3. So S3 is designed with almost unlimited scalability, and it can store both relational database data and non-relational data. With the S3 as a foundation, we have a rich analytics service on top of it to support like different type of workload. They're all purposely built because we believe one size doesn't fit all. If you want to do machine learning, you need a service that's designed to handle machine learning the best. If you want to do the non-relational data, And a DynamoDB, that's key value store, will be best to handle such workload. So all the service we design, we have the cost in mind. We want to build the service that's cost efficient so that anyone can use it, you can afford it. The S3 only costs you 2.3 cents per gigabyte per month. And if you query through Athena, it only costs you half cents per gigabyte you scanned. And even with our high-end data warehouse service, Redshift, the cost is $100 per terabyte per year. So it's only 1/10 of the cost of traditional data warehouse. And with our BI to QuickSight, you can get access, give access to all your employees. It only costs you 1 cent per minute. So it's like 30 cents per half hour when you use it. And if they don't use it, there's no cost. So a lot of our customers use our data lake solution to do analytics. Yeah. Sure. You mean this one? OK. Do you have any questions? Or? Oh, OK. OK. Yeah. So a lot of customers use the data lake to do analytics on it. The Fortnite, the one I just showed there, that's one example. So it's a game company, and game can generate a lot of data. So this game, they have 100 million users. So the game is itself, since it's free to play, so they really have to keep gamers' attention to attract them to play the game so that they can do the microtransaction, buy stuff in the game to make money. So with a lot of data coming in, and they also need to make the real-time decision to adjust the game to keep the attention of the gamer. So Epic Game, they use the data lake, they use the Kinesis to collect the data, the real-time data from various data sources, and the data coming in either through the bench pipeline so that you can do more advanced analytics to get insight to make maybe a long-term decision, and also the real-time data coming in using DynamoDB to do the scoreboard to show the computation to really motivate the user. And they all done on AWS. Depend on the purpose. So for the EMR, you can do both bench and streaming. And the DynamoDB here, scalability definitely is one of them. And also that it's very fast. It's a global voice, so that you can easily handle, since the gamer come from all the world, right? So with the kind of global service, you can easily handle like the cross-region, and also if there's a disaster recovery, it's all handled behind the scenes. So you don't need to worry about this. Scalability, also the high performance, yeah. So data lake is a great solution. But it's hard to set up if you do everything by yourself. So if you have all the data, like just a data silo, it's probably easy to manage the security for a user. It's like you just don't lock the room, and then people don't have access to it. But with the data lake, all the data is put in a central location. So each user might have a unique profile, and different team will have different access. And if you have to do this like per user, it can take you months. And also with multiple service, each service have their different, probably different interface, different security requirement, and set up the hundreds, thousands of users, the security part per user is also difficult. So the lake formation is here to help you simplify all the setup. So it's not only like you just need to point where your data is, and the data lake formation will be able to crawl the data, get the data catalog, put it in a central location so that all the analytics service, data processing service be able to access it. And you can easily manage the data movement, data transformation, and also the security. So that give you a single interface. You just set up your security there. And then underlying, it will depend on what service need and set up everything for you. So that shorten your time to build a data lake from months to days. Which one? QuickSight? So QuickSight can access data on S3 directly. Yeah. SageMaker, actually, probably Ben knows this better. SageMaker. Thanks, Ben. Okay. Yeah. Yes, that's a glue data catalog. Yeah, so it's in a central repository. So like most of the analytics service can access the data catalog so that they can easily share the data and doing process. So I'm going to talk about just a couple of services in more details. So Amazon Redshift, as you probably all know, does anyone don't know Redshift? Okay, good. So that saves time. So Redshift is our purpose-built data warehouse that can scale to petabytes. And what we're doing is to keep increasing its scalability and also performance. So today I'm going to talking about 3 features of Redshift that scale Redshift to virtually like unlimited number of users, and you can support like unlimited data size, and also still 10 times faster than traditional data warehouse, and 1/10 of cost with traditional data warehouse. So this first feature we call concurrency scaling. So usually in your organization, the workload is really static, right? So it will change by hour, by day. So in the Monday morning, probably everyone coming in, they want to look at the dashboard, they want to run a report, and you might have very high spike coming in. But with limited hardware, the hardware, you will only be able to process a certain amount of requests, and the rest will queue there. To solve this, and we provide automated scaling feature there, so that can add hardware behind the scene automatically for you. So when the request is queuing, and we will detect that, and we move the request to the second cluster that we created dynamically, and to help you to handle the request as fast as possible. So the best thing is whenever your Redshift cluster is running, and you accumulate credit for using this feature. So based on our statistic, 97% of our customers will be able to use this for free. So every day your Redshift cluster running, you accumulate 1 hour credit to use concurrency scaling. And this will accumulate up to a month. So the question is, when you use concurrency scaling, does it use a cache or does it use? So that's not the case. So for concurrency scaling, we actually adding additional hardware there. So kind of create a second cluster for you, so that you can use the second cluster to run the queued request that they want to use the resource on your main cluster. So the nice thing about this feature is it's smart enough to be able to get the data from the snapshot, or like depending on where the hot data is, it can also probably access the data from the main cluster, so that it doesn't need a long time to hydrate the data. So the whole cluster can be ready in just like seconds, and then it can start serving query. So it's really like free your main cluster that you can use that dedicated for your high priority workload. And for the others, you can use the second cluster, and it's automatic. So whenever your workload finish, the peak hour finish, and the cluster can be shut down automatically. And you only pay for the time that you have the query running on the concurrent cluster. And that one, for the 3% of customers who probably need to pay additional for this second cluster, and it's charged per seconds. It's not per hour billing. So the second feature I like to highlight is Spectrum. This is not a new feature. So we have this one already in production for many customers. It's been there for more than a year. And Spectrum can extend your data warehouse to your data lake, so that you can use your Redshift cluster to access your data on S3 without need to loading them to Redshift first. So this extends your data warehouse from petabytes to exabytes. And the Spectrum layer is serverless. It's a serverless compute. It can scale automatically. So based on your workload, it's smart enough to know that, oh, what's the most efficient way to calculate it. So you don't need to worry about how much compute you use. You just need to design your schema on the S3 to make sure they're able to efficiently read the data and reduce the cost. So the third feature to increase the scalability is called elastic resize. So elastic resize allow you to dynamically scale up or scale down your Redshift cluster. So for example, if your workload is heavy during the day, but almost no one uses it at night or at the weekend, and with the elastic resize, you can add resource, hardware, more nodes to your cluster to be able to handle this heavy workload. And then you can scale down at night or weekend and to reduce the cost. So with all those three features, now the Redshift cluster can virtually support unlimited number of users, unlimited data size. Besides scalability, Redshift also keep improving the performance. Compared with 6 months ago, Redshift's performance is increased by 3 times more. And all those, they're transparent to our customer. They don't need to worry about, oh, do I need to upgrade my cluster? Because it's a managed service. So everything's managed for you. And the upgrade will happen automatically. If there's any node failure, disk failure, they are replaced automatically. And you don't need to worry about the maintenance overhead. You just enjoy the great performance there. So depending on the workload, for some workload, Redshift is 16 times faster than other data warehouse in the market. And the cost is only 1/10 of it. So we use it ourselves. Actually, this morning, someone asked me, oh, Amazon use Oracle. Yeah, Amazon use the Oracle. So we used to be an Oracle shop. So we have 50 petabytes of data warehouse, and there's a bunch of Oracle rack. So those Oracle servers really cost a lot. And now we moved almost all of them to Redshift. So not only we get better performance, better scalability, now we have 100 petabytes on our Redshift cluster, Redshift data warehouse. And we get lower cost, better performance. So here's another example that a customer migrate from traditional Teradata warehouse to Redshift. So with Teradata, they have, besides the initial 1 million capital expense, that's the initial cost, and they still need to pay $200,000 per year for the maintenance and the support. And with the Redshift, the cost is only 20% of that, so $40,000 per year to handle the same workload and provide better performance. So next, I'd like to talk a little bit more about QuickSight. So as mentioned earlier, we believe that all the employees should have access to the data. And the traditional BI tools usually have the client-server architecture so that you need a license per user who need to use the BI user dashboard. So that's limited, which user, how many users they can get access to the data. And the QuickSight, we designed it to be easy to use and also scale very well for a large number of users. So you only pay per use, and you pay 1 cent per minute when you use it. If your user doesn't use it, you don't pay for it. And if you have a heavy user that maybe use it 4 hours a day, and the cost is capped at $5 per month. So it's still very cheap for you to use. And in the past couple of years, we keep adding new features to QuickSight and to make it more rich and more suitable for business intelligence. So now you can embed QuickSight in any of your application using standard JavaScript SDK. And as long as depend on what's the usage, and you only pay for what you use, so that is very cost efficient, affordable to use. So one of the customer, NFL, and they use the QuickSight dashboard for the game to show more detailed data of how the game is performing. And football actually a quite data-intensive game. And with QuickSight, they're able to provide this dashboard to hundreds of their users and 32 clubs of their partners, so that they can really show at any moment how things going. And we have more customers that are using the QuickSight at large scale. Rio Tinto, they provide the QuickSight service to 20,000 of their employees for the safety, to help them to improve the safety. This is a mining metal company, so safety definitely is their #1 concern. And another customer, Willet Health, they use QuickSight to provide inside information to 900 of their clinic healthcare organizations and thousands of users. And again, Amazon.com, so that we're always using all the service we build, trying to use all the service we build, provided to thousands of employees. So there's some new exciting feature about QuickSight I'd like to talk about. So the first is the machine learning insight. So customer like just show a static dashboard, although that's information, but does not give you enough like to help you make decision. That's why we added the machine learning capability to QuickSight, so that can help you detect the anomaly detection, and it can do the forecasting and also show the narrative automatically. So help you to like filter the information and quickly find out what's most important there.
What is auto narrative?
Auto narrative? I'll show example in the next. Yeah, thanks. So here's the example to show how the anomaly detection is performed. So with the graph, the chart showing there, and QuickSight can detect, oh, there's some anomaly, the pattern there. And it can actually detect the call-related dependency here. For example, that this is the office supply company that's showing the sales. And there's, in the APAC, there's 15% more sales compared with Euro. And not only the QuickSight can show that, oh, there's some kind of a little bit un-Euro sales activity, it can also show you, drill down to show you, oh, this is because the SMB segment contribute to this 15% increase. And compared with Euro that they only probably contribute to 30%, now they contribute to 50%. So this helps you like quickly find what's the related information instead of you have to do it manually in the past. And it can help you to do the forecasting quickly to like predict what's your next month's revenue or next year's revenue. And it can do the auto narrative, kind of like summarize the information there and showing it in the dashboard, highlight what's the important, what's interesting there, so that you don't need to like look at each line by line and look at all the data point to get to what's the most interesting part there. Yeah. The workshop, I think, have part of the QuickSight, but probably not in that detail because we have a lot of service we want to cover in the workshop. We want to show you the full end-to-end application. So it probably doesn't have that detail.
Go back to the previous.
You mentioned automatically excludes bad data. Without going into a lot of detail, you have control over what bad data means. Can you adjust the parameters so that if there is an anomaly and that's true, the users have control over exactly what bad data is?
What bad data is?
Yeah,
so this
automatically excludes bad data.
Yeah. So this one is like using machine learning. So machine learning, like definitely will need to go through some training process. Good question. So I think I don't know if Ben, you know. Yeah, we can take that during the break. Okay. Sorry. So this is just overall for the like very quick introduction about the analytics workload. There's okay. So now let's Ben will like continue to discuss some of the new exciting service like we just launched last year.
Okay, thank you so much. Okay, so we're actually a little bit behind schedule, so what I'm going to do is try to fly through this use case of building new applications in the cloud, and then we'll save the lift and shift for this afternoon. So again, When we look at customers, we talk to them about what their requirements are, whether it's ride hailing with Lyft, media streaming with Netflix, social media with Pinterest, or dating applications like Tinder. We're hearing that there's, basically orders of magnitude beyond what we're used to, right? So in terms of scale, it's millions of users. Data volumes, just when you got comfortable with terabytes and petabytes, we have customers today storing exabytes of data, individual customers storing exabytes of data in S3. People want global footprints for their applications, right? They want to be able to deploy around the world and be close to their users for low latency. There's a saying we use internally that microseconds are the new milliseconds. And again, our customers are pushing us for more, and we're delivering with these services I'm about to talk about. Request rates in the millions per second. And again, developers want access to these APIs that they can call and get sub-second response time. So we talked a lot about some existing database services like Amazon's RDS. This is our relational database service. I'll talk a little bit more in this session about DynamoDB, which is our key value and document database. For in-memory, and again, people that want that microsecond access, we've got a service called Elasticache, which is a fully managed Redis or Memcached service. For graphs, if you're working in social media, you know that graphs and tags are important. We've got Neptune. And then we recently at reInvent last year announced TimeStream and QLDB. And I'll go into each of these in a little bit more detail. And try to wrap this up in about 5 minutes if possible. So again, DynamoDB is performance at scale. We'll talk about some numbers on Dynamo, but basically it's consistent single-digit millisecond access times. It's completely serverless. You don't have to worry about provisioning storage or capacity with DynamoDB, and we'll talk about some improvements we've made there to make it even easier to use. Again, comprehensive security with encryption, right? Our CTO always talks about encrypt, encrypt, encrypt. It's super critical these days. And then global footprint, where we now have the ability to have multi-master updates in multiple regions with Dynamo. So if we talk about scale, our parent company, Amazon.com, is doing more than 20 million requests a second against DynamoDB. Snapchat has 150 million active users pounding on Dynamo every day. And Samsung has over a petabyte of data in DynamoDB today. So I'm an old-time relational database guy, and I sort of grew up with Jim Gray's transaction processing book. I still have it. And we haven't forgotten about some of these ACID properties that we learned about in school. And so working with Dynamo, historically, you've got to update one table, and then you've got to update a second table, and you've got to make sure that either both those updates succeed or they get rolled back. Historically, this was a manual process for the DynamoDB developer. What we've done is added transaction support to the DynamoDB interface, where you can basically start a transact write items block, have multiple updates within that transaction, and again, they all succeed or they all get rolled back. Another feature we announced, that's ACID transaction support is now generally available in DynamoDB. We also made it easier to scale up and down. So you guys know when Dynamo first came out, you had to provision read capacity units and write capacity units. We've now added the ability to have Dynamo scaled automatically for you based on your traffic load, and you don't have to worry about that provisioning anymore. And it's pay for only what you're using. So that's a nice usability and cost savings improvement there. So TimeStream is a time series database. If you think about stock quotes coming in, or if you think about IoT devices generating data points, time series database called TimeStream is designed to be 1,000 times faster and 1/10 the cost of relational databases. So this is basically an append-only data stream that's going to come in, scales to handle trillions of events a day. We've got a bunch of functions in the time stream database to handle smoothing issues. So for example, you've got an IoT device that's sending temperature, 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 temperature every second, and then it kind of drops out, and you don't hear from that device for a minute. And then it comes back online. Maybe you had a transient internet event. Maybe your radio went down. We've got functions built into the time stream database to smooth those missing data points over so we don't skew your results when you do those aggregate queries. And again, it's serverless. You throw as much data as you want at time stream, and we'll scale out the storage and the compute. So Quantum Ledger Database, this is a fully managed ledger database running on AWS where you need that immutable write capability, whether it's chain of custody. I know a lot of folks in big pharma have applications where they need to adhere to strict compliance regimes. QLDB is going to give you that cryptographic integrity of that data and an easy SQL interface to get it out. We've got managed blockchain in preview right now. And again, we can talk about the differences between QLDB and blockchain, but basically QLDB is a centralized database managed on AWS, where managed blockchain is decentralized, where everyone has their own copy of the ledger. And if you want more information on anything I just blasted through, there's some links. If you just search AWS and any one of these session codes, it'll bring up the reInvent sessions that I pulled these slides from. So I'm a little bit over. Thank you very much. We're going to get to the last use case of lift and shift this afternoon. Thanks a lot, Twitch. Okay, great.